On this second lesson, we are going over a few features of straight lines that you will need to know in order to solve the questions that you'll have eventually. First, you'll need to recognize lines by their equation. And there are several ways in which a line can be presented to you. The one that you are more used to is probably this one, y equals mx plus c. But if you have just y equals a number or x equals a number, this is also a line. Take a look at this. Let's say that you have a line like this, okay, a straight horizontal line. How can you define this? This is cutting the y-axis on this point over here. Let's call it A. So how would you define this? This is completely defined if you write it like this, whatever this number is. So let's say it's 3. If you just write y equals 3, you'll know that this is going to be a straight horizontal line. It doesn't depend on x. It doesn't matter what x is, y is always going to be 3. Similarly, if you have a vertical line, and let's say that now this is also 3, if you just write x equals 3, this is going to be a straight vertical line. It doesn't depend on y, so you just write it as x equals 3. If you have a line with whatever other inclination, then you must write it as, and this is the way that you probably learned in previous years, y equals mx plus c, in which c is here the y-intercept, and m is the gradient, the inclination of the line, calculated the way that we talked about in our previous lesson. But you may have other two ways of a line being represented. So let's say that we have minus 2 equals 3x plus 4. This is also a way to represent a line. If you see it this way, it means that the points 2 and minus 4 is going to be the points. No, the point 2 minus 4 is going to be a point belonging to this line. This is what you have over here. Y minus ya equals m x minus xa, where m is the gradient, and xa and ya are the coordinates of a point A that belongs to that line. If you can also see it like this, in which ax plus by plus c, in which a, b, and c are just numbers. And they are all interconvertible. You can convert from one to the other. Let's start with this one, and I'm going to go from this one to this over here. So you can just expand those brackets over there. I'm going to send already these two to the other side. So 2 plus 3x plus 12. Now I'm going to put this way first. So this is going to be 3x plus 14, right? So I just transform this into this, which is this form. And I can put it also like that. So I have 3x minus y plus 14 equals 0. I just sent this y over here, and I flip the position of the equation, and I have this equation written as this, in which a is 3, y is minus 1, and c is 14. Let me just take this out now. Points belonging to a line. To see if a point belongs to a line, you just have to plug in the coordinates of that point into the equation of the line. Really doesn't matter in which form. And if the point belongs to the line, you will see that the resulting equality is satisfied. What does this mean? This means that after you plug in the coordinates of a point into the equation, you will no longer have variables. You will have numbers on both sides of the equal, and if these numbers are the same, you have proven that a point belongs to a line. So let's say that we have just, I'm going to use this equation of the line. 3x plus 4. Let me just erase this. Y equals 3x plus 4. And I want to see if the point P 1, 7 belongs to the line. So 1 is the x coordinate of the point and 7 is the y coordinate of the point. So I plug this over here and I plug this one over there and see what happens. So I have 7 equals 3 times 1 plus 4. 7 equals, this is 3 plus 4 is 7. This is true. It checks. So I have just proven that the point 1, 7 is the point that belongs to this line over here. So if this is 1, I will know that that is 7 is a point P that belongs to this line over there. How do I know if two lines are parallel or perpendicular? If two lines are parallel, it's obvious that they should have the same inclination. They will never meet anywhere. That's the definition of what two parallel lines are, which means that the inclination is the same. What measures the inclination? It's the gradient. So if the gradient of two lines are the same, means that the two lines are parallel. What about perpendicular lines, the ones that make 90-degree angle? In this case, the gradient of one in relation to the other is going to be such that if you multiply the gradients together, the result is -1. You can check this on this form or rearrange it into whichever form suits you best. What if you have a parallelogram? Parallelogram, like the name suggests, will have sides parallel to each other. Okay, so let's say that you have this parallelogram. How do you prove that 4 points A, B, C, and and D form a parallelogram? You have several ways. You first need the information about the coordinates of the points. In the first method, you just calculate the lengths of opposite sides and show that they are the same. You already learned in the previous lesson how to calculate lengths of between 2 points. So if you calculate the length BC and the length AB, and then calculate the length AB and CD, you are going to see that if this is a parallelogram, two of them are going to be the same in pairs. So you have two lengths that are the same, and the other two are also going to be the same. If you do so, you have proven that it is a parallelogram, because obviously this only happens with parallelograms. Method 2, calculate the midpoint of the lines connecting opposite points and show that they are the same. What do I mean with this? Again, we have here our parallelogram, A, B, C, D. Midpoints of the lines connecting opposite points. What are opposite points? Opposite point to D is B. And opposite point of A is C. If you calculate the midpoint of AB over here, and if you calculate the midpoint of AC, which is over here, and if you see that the coordinates are exactly the same, you have proven that this is a parallelogram. This is method 2. Method 3, calculate the gradient of opposite sides and show that they are the same. You wouldn't know in most situations what opposite sides are, but if you get the gradients of all possible lines, and you only have 4 of them, you will see that if this is a parallelogram, you will find 2 lines that have the same gradient, and the other 2 lines will also have the same gradient. It's a similar approach to method 1, but now instead of lengths, it focuses on gradients. Which one will you use? It will depend on the question. It will depend on the information that is provided. It will depend on the information that you already have. And ultimately, it will depend on you. There is no preferable way. The only criteria that you are going to use to decide which one you want to use is the one that seems simpler to you. And with this, the lesson is concluded.